starting with this presentation, it's going to be more class-like. So we're going to have objectives, and everybody's going to meet those objectives. And for this presentation, we have two. One is understanding the source data sets that were used to build NHD+, and then finally understanding what the content is when you download it, what the pieces, parts are. Tommy covered this a little bit, but I'm going to take a more data set-oriented approach to it. Okay. The source. I guess I am moving. All right, good. The source data sets, this is a slide that Tommy showed, are the National Hydrography Data Set, and that's on top for a really good reason. We call it NHD+, not WBD+, or NED+. That's where the stream network is. The Watershed Boundary Data Set provided drainage divides, and the National Elevation Data Set, which is now referred to as the 3-depth program, but in all the NHD plus literature and in the data set naming convention, you'll see NED, which is the National Elevation Data Set. We did all that before 3-depth existed. So we're trying to catch up, but we haven't yet. All righty, so in the data sets that you get with NHD+, you will get a snapshot of each of the 3 data sets that were used to build NHD+. So you have all of the source data that we started with. And the NHD snapshot contains the stream network. It contains the water bodies. Each of those features has a feature name if it was available. We have the NED snapshot, which is a DEM. We have the WBD snapshot, which is the hydrologic unit boundaries. This is the web page. These 3 data sets are all maintained and served by USGS. It's important to grab the snapshots from NHD+. If you go to USGS to get the data, you will get data that is not necessarily what we started with. So you always want to use the snapshots that come with NHD+. But all the documentation is on the USGS webpage. We have not tried to replicate USGS's documentation. It's excellent. So here is where you find everything there is to know about NHD. We'll talk a little bit about it. NHD comes in 2 flavors. There's the medium resolution NHD, which is 1 to 100,000 scale, and better because we've improved it somewhat, and a high resolution NHD, which is started out at 1 to 24,000, but it's getting more like 1 to 5,000 and 1 to 2,500 and so forth. There is a high resolution NHD Plus being built, and we'll talk about that later in the workshop. EPA is the data steward for the 1 to 100,000 scale medium res NHD. We pulled a snapshot in April of 2010 to build NHD Plus version 2. Then we made a lot of updates to it. We updated feature names. We did a lot of updating on network connectivity, connecting up isolated networks, fixing errors in the connectivity. We also added water bodies to support the EPA National Aquatic Resource Survey for lakes and ponds. And finally, the most up-to-date medium resolution NHD is in the NHD Plus. It is not at USGS on the NHD webpage. Okay, 80% of the NHD features are in the stream network. So that's the primary feature class. It's called NHD Flowline. It has 6 different feature types. There's stream river, canal ditch, pipeline, artificial path. Connectors are non-specific geometry where we knew, or the person editing NHD knew there was a connection but didn't necessarily have the geometry for that connection. And finally, there are coastline features. The attributes are things like feature name, The feature names come from the Geographic Names Information System, which is GNIS, and so each unique feature has a GNIS ID, which goes with its name. So when you have 50,000 mill creeks in the U.S., each one has a unique GNIS ID, which provides you with a unique name. Feature type. The feature types are on the left, and they're all in attribution on the features. We have a reach code, which you'll hear a lot more about as we progress through this day. The reach code is the external ID, which is designed for linking things to the network. It is assigned, it is persistent, it does not change unless there's an error in the NHD, or unless somebody goes out there with a bulldozer and starts digging new trenches in the landscape. Feature length, the direction of flow in the feature, and finally, if the feature flows through a water body, we link the feature to the water body. So you have a link from the network to the water bodies and back and forth. The most important aspect of the NHD is that it has a flow table, and it tells you how features exchange flow. And that power is what enables the NHD Plus and the NHD to navigate the network upstream and downstream, and we take full advantage of that in NHD Plus. Water bodies and areas, in other words, polygonal features, are the second major content in NHD. It's 14% of the NHD features. In the water body feature class, there are lake ponds, swamp marshes, reservoirs, which, and I have to explain, reservoirs aren't what we think of. They are not impounded lakes. They are constructed basins that sit off to the side of the network. So if you're looking for reservoirs as we understand them, in other words, a dam and a big water body, those are lake ponds in NHD. It's an important point to remember. We have playas, ice masses, washes, and estuaries. The area feature class is primarily polygon features that are also linear features in the NHD flow line. So when you have a wide river like the Mississippi, it shows up as linear features in NHD flow line. It also shows up as polygons in NHD area. Canal ditches can also be aerial features. There are not a lot of aerial features at 1 to 100,000 scale for canal ditch. Areas of complex channels. These are braided areas where the compilation of NHD, they drew a boundary around the complex channels, the braids, and just turned them into, a, quote unquote, an area. And there's a linear feature that goes through those areas. And finally, sea ocean is our last area feature. The attributes of water bodies and areas are feature name, GNIS ID, feature type, and reach code again. Okay. And finally, we have what we always refer to as landmark features at 6% of the NHD feature types. These are primarily there for making pretty maps. They do not play a role in NHD Plus. We have them there for the purposes of mapping. They're dams and locks and rapids, springs and sinks, et cetera. The second data set is the WBD. The WBD is a nested set of hydrologic unit boundaries. The first, they divide the country up into hopefully standardized and persistent reporting areas. The first division is what's known as the two-digit Huck, meaning there are two digits that describe it. Huck 201 through 18 are in the continental U.S. from Maine to California. 19 is Alaska, 20 is Hawaii, 21 is Puerto Rico and the Virgin Islands, and 22 is the Pacific Island territories. each level of WBD adds 2 digits to the code. So you go from a 2-digit code to a 4-digit code, which is divisions of the 2 digits. There are 202 of those in the continental U.S. You add 2 more digits and you get the Huck 6, and there are 336 of those in the continental U.S. You add 2 more digits and you get Huck 8s, 2121 in the continental U.S., Huck 10s, and finally Huck 12s. The Huck 12s, there are 86,000 in the continental U.S. These are the boundaries that we used as drainage divides when building NHD+. You'll notice that there are areas, the average size of a Huck 12 is anywhere from 42 to 160 square kilometers. I think they average around 90. You can see at the Canadian border and at other places like in South Florida where the Hucks are fairly large. We have large Hucks up in the Great Lakes. The third data set is the NED, or 3-depth. We used a 30-meter processing grid to produce NHD+. However, the data is from the best available NED. So you can see from the legend that most of the NED, when we took our snapshot in 2011 to 2012, was 10-meter resolution. And it's resampled to 30-meter, and we process it as a 30-meter grid. But the accuracy of the data comes from the 10-meter NED. And then the blue spots are 1/9 arcsecond or 3-meter. So there was some very, very detailed elevation data that went into NHD+. Okay, so you get those 3 snapshots. All the documentation can be found on USGS web pages. Now we come to what you get in the plus part. In this picture, the brown ovals are raster data sets. The blue are vector data sets. The purple are the original snapshots of NHD, WBD, and NED. And the green are attributes. You can see we have tons and tons of attributes. The vector layers consist of, the first set is a set of 6 data sets called the burn components. These are primarily provided as documentation of the process that was used to hydroenforce the elevation and produce the NHD+ catchments. The burn line event, water and water body come from NHD. The burn add line and burn add water body were extra features we needed for hydroenforcement that were not in NHD. Land C is a data set, a polygon data set that is used to make sure that the water flows off the land into the ocean. And then we have sinks, which are points where the water disappears into the ground, does not contribute to the drainage area. And all of these were used in hydroenforcement to the DEM, and from that we produced the catchments, which is the primary data set in NHD+. It's the data set that links the network to the landscape. Here are the raster layers. We produce a flow direction raster. All of these are grids in NHD+ version 2. We have a flow accumulation raster. Catchment seeds, these are the seed points for producing the catchments. We did fill and spill in some areas, and filled areas is another grid, FDR null. We'll get into these a lot more as the day wears on. The hydrodem is the hydroenforced DEM. So for those folks who want to know what it looked like when we were done, but before we produced the catchments, that's it. And finally, the catchments are also provided as a raster. They're a vector data set and a raster data set. And then we come to our rich set of attributes. We have 7 data groups of attributes. The first one is NHD plus flowline VAA. We generally refer to these as the network VAAs, the value-added attributes. They are very powerful. You'll learn lots about them later on. We have a data set that has slope. We have raw elevations. We have smoothed elevations that are processed in NHD plus so that the water always flows downhill. We have headwater node areas, which is basically just the drainage area that drains to the top of each network start. We have catchment attributes that we've allocated to catchments, runoff, temp, precip, NLCD. We have drainage attributes where we've accumulated all those attributes down the network, so at any point on the network you know not only what is allocated to the catchment there, you also know the entire drainage area. And then finally, obviously, the thing that we were after from the very beginning is stream flow. And we have mean annual stream flow and velocity, and we have the 12 mean monthlies. So that is the end of the quick tour through what you get when you download the data. Are there any questions? Nope. All righty. We do have. Yeah. Wait.
Where are we here? We're recording, so please identify yourself. So this is Dave Simpson. So the NHD snapshot that you took in 2010, has that evolved with updates to NHD, or is that just a static snapshot that
we extracted from the USGS database a snapshot of medium resolution NHD and in April of 2010, and then we updated that. The Sparrow modeling group that Tommy mentioned and that Rich is part of spent a lot of time reviewing the network, connecting up isolated networks. We fixed names, we added names. We did a lot of updating, and then that became the snapshot, if you will, that went into the NHD Plus build process.
Okay.
Yeah. There is no bathymetric data in NHD. Okay, the question is, has anybody augmented the NHD to reflect bathymetric data in reservoirs? And I know that some people have done that for individual reservoirs. Having done it across the country, I'm not aware of anyone. Okay.
No, it's up here still. The mic? Yeah. I think so. Should be.